In this example, we're going to be writing a polynomial in standard form with the given zeros. A few other qualifiers on there, but that's the main important part. They give us some zeros. We have zeros at 2, -1, and then a couple of real numbers, 3 minus the square root of 2 and 3 plus the square root of 2. What you do in order for you to find the polynomial is to write these zeros with their corresponding factors. If 2 is a 0, that means that x minus 2 is a factor. You put x minus in front of each one of the numbers, essentially. So our next factor would be x minus a -1, or x plus 1. The next factor is going to be x minus the number. The number this time, though, has two terms, but we want to subtract the whole number, not just a part of it. So you want to group them together, so we need to put an extra set of parentheses in there. And then x minus, in parentheses again, 3 plus the square root of 2 for us to get that 0. If they didn't say to put that into standard form, this would be totally fine, but we do want standard form, which means we do not want to have any parentheses. There's two ways of handling this problem. The one that usually causes students the least amount of errors is to get rid of this nested set of parentheses here in each one of these last two sets of parentheses. So I'm going to take the subtraction and distribute that into both. And then you have some choices. We have 4 parentheses that are all multiplied together, which means we have 3 multiplications. 1 here, 1 here, 1 here. We need to do those multiplications, and we're going to do them one by one. So you can multiply any pair that you would like to multiply by. Pick a pair of parentheses and multiply those out. I will give you a hint, though. When you have conjugates, so if you look at these last two zeros, they both start with a 3, they both end with a square root of 2, but the sign is different in between. When you have that pattern, those will get things to cancel out if you multiply them. And I would like things to cancel out sooner than later. So I'm going to multiply those together first. So I'm not going to do anything with this x minus 2, not going to do anything with the x plus 1. I am going to multiply out those two trinomials. So using the distributive property, x times x gives me x squared. X times -3 is a minus 3x, and x times the square root of 2 is a minus root 2x. And then doing the same thing with our other two terms, distributing the -3 and the square root of 2 in, here's what we end up with. And if you take a look at all 9 of those terms, anything with a square root is actually going to cancel out. We have here a minus 2x, minus root 2x, and here a plus root 2x. Those are opposites, so those cancel. We do have a 3 root 2, which is a positive, and a -3 root 2. So those cancel. So everything there in red, those are just going to cancel out. So if I combine some like terms, what we end up with in our next step, well, we have an x squared to start with, and then our x's, -3 minus 3 would be a minus 6x, and then our regular numbers, 9 minus 2 is 7. So you can see if you multiply the things with conjugates first, you do end up with something that simplifies relatively quickly. All right, the next multiplication I'm going to do the next, or the first two, I guess. That's just a matter of foiling, so if we FOIL that out, we do end up with an x squared plus x minus 2x minus 2. That was a minus there. So x squared plus x minus 2x minus 2. And if we combine those two terms in the middle, We've now done 2 of the multiplications. There's only 1 multiplication left. Need to multiply those out. So again, using the distributive property with these 3 terms, multiplying each one of those into the other 3. And then from there, we do have some like terms here that we can combine together. There's only one x to the 4th term. For our x cubes, we have negative 6 minus 1, which is a negative 7x cubed. For our x squared terms, 7 plus 6, which is 13, minus 2, which would give us 11 of those x squareds. For our x's, negative 7 plus 12 is 5, and then our constant on the end. We were supposed to come up with a polynomial of least degree with real coefficients in standard form that have the given zeros. Now that we've multiplied all of this out, we put a little f of x equals in front of that, and we now have a polynomial that fits the description that they asked us to do in the book. Really easy way to go through and to check your work on this would be for you simply to type in what it is that we have for our equation, this one, into a graphing calculator. And then you should be able to see x-intercepts at the original zeros. So let me get that typed in here. Clear out my last problem. So we have x to the 4th minus 7x cubed plus 11x squared plus 5x minus 14. And if I hit the graph button, it looks like I typed it in wrong. X to the 4th minus 7x cubed plus 11, forgot my x, plus 11x squared, there we go, plus 5x minus 14. I could see that my zeros were not lining up with the given on the graph. So when I looked at the graph, I saw that I did not have x-intercepts at 2 or at negative 1. So either my equation here was wrong or I typed it into the calculator wrong. Most of the time I do something wrong in the work, which is why we check our work. But that time I typed something wrong into the calculator. So now I think I have it right. So I think it matches this one. So let me hit graph again, and let's see what we end up with. Okay, let me change my window a little bit so we can see a little more zoomed in view. I can change my Y's a little bit too to make this a little easier too. All right, so here's our graph. And if you take a look, we do have an x-intercept at negative 1, just like it said in the original problem. We do have an x-intercept at 2. There is one number here that's a little smaller than 2. That's what 3 minus root 2 is. And then we have one that's a little bit bigger than 4, and that's what 3 plus root 2 is. 3 plus root 2 is about 4.4, which is where that x-intercept is. So I'm feeling really confident that I did that problem right.